Hello everyone. In today's video we are going to be talking about rounding numbers. Okay, now first we're going to define what this process is. We're going to talk about a little bit about what it's good for, basically, and then we're going to talk about how it's actually done. So, first of all, what it is. Rounding a number is telling you about how much this number is without giving you that exact number. So, for example, let's say that I tell you that in a city there are 19,012,623 people. And then you could say to me, so there are about 19 million people. And you would be correct. Yeah, there are about 19 million people. What you just did there would be rounding this number into this number, right? Why do we do that? Why would we do that? Because the difference between the two is so small that it doesn't really make a difference, especially when it comes to numbers like this. So when you're describing, for example, how many people there are in a city, we say, for example, that in Athens there are about 5 million people, right? We all live in Athens, and in Athens we say that the population is 5 million people. That means that at any point in time, there are going to be about 5 million people in Athens. But it's probably never exactly 5 million. It might be 4,999,852. It might be a little more, so it might be, let's say, 5,024,785, with people coming and going all the time, entering the city and leaving the city. That number is changing all the time, right? So saying that there are 5 million people in Athens is not true. There is a small difference between this estimation and reality, but it gives us an idea of about how many people there are at a given time. It's like what we were talking about with averages, basically, where we don't know exactly how much it is, but we have an idea of how much it is. Now, to say, for example, that there are 10 million people, that would be wrong. So there's a process to this, to rounding numbers. Uh, but you might be wondering, why use the word rounding, right? Because what we are doing is making the numbers round. See how the zeros are all round, right? Well, what we're doing is we're putting more zeros into the number. We are making the number so that it has more zeros. So to give you an idea of that, 10 is a round number. 200 is a round number. 5,000 is a round number. 6,000, 60,000 is a round number. 1 million is a round number. 5,268,923 is not a round number. Why? Because it doesn't have any zeros at all. The more zeros that it has in it, the rounder that we consider the number, right? So if you make most of the digits here 0, and you just say that, okay, this number is about 5 million, right? I just rounded it because I just put in so many zeros that are all round. So how do we do that? For example, how did I round this number down to 19 million? Well, first things first. You need to know a few things. What digit am I rounding to? what is the number right after that digit? And you should be writing this down. Although it's also on Mr. Costas's worksheets, pretty much the same thing. So you can find it there as well. Just have something next to you with a theory when you go into the worksheets. If the number right next to the digit that you are rounding to is, if the number right next to the digit that you are rounding to is 0, 1, 2, 3, or 4, then we turn it and every number after it into zeros. Well, what happens if it's more than that? If the number right next to the digit that you are rounding to is 5, 6, 7, 8, or 9, then we turn it and every number after it into zeros, and we add 1 to the number to the number in the digit we are rounding to. Now, what did I just say? Let's explain that. There's no way to understand this without actually seeing examples of it. So, in this example, this is what I would have done if someone had given me this number and had told me, round this number to the hundreds of thousands, right? Now, what that means is that I am rounding to this right here, right? These are the hundreds of thousands. I'm going to underline. Come on, why didn't you underline? Okay. So now we're not cooperating. Okay, I'm going to turn it red. Can we do that? Yep. So I want to round this number to the hundreds of thousands. That is this digit right here. Okay. What did it say that we do? What is the number right after that digit? Well, right after this digit here is a 1. So we are in this case, the first case, where the number right next to the digit that we are rounding to is 1. So we turn it and every number after it into zeros. The 1 becomes 0, and every number after it also becomes 0, right? And so the number becomes 19 million. Now, if someone had told me, round this number to the thousands instead of hundreds of thousands, right? What I would have done is, I'm not rounding here anymore, so I'm turning it black again. I'm rounding to the thousands, okay? So I would have looked here. I'm rounding to this digit. Okay. I would look to the number right after it, which is 6. Now we're in the second case, where the number right after the digit that we are rounding to is 6. It's a 5 or more, basically. It's greater than 5. Greater than or equal to 5. Then I would turn it, so the 6, and every number after it into 0, and I would add 1 to the number in the digit that we are rounding to. So I would add 1 to this 2, right? So this would become, all the other numbers would stay the same. So it would be 19 million. All the numbers I mean to the left, right? 19 million. And then this here gets 1 added to it. So it becomes 3. And then the rest of these become 0. So now I just turned this number into 19,013,000, which is, if you ask 2 people, right? This city has 19,012,623 people. When you ask 2 people, how many people are in the city? One person says 19 million, the other person says 19,013,000. This person is more correct, yes, but the number is less round. Okay, so it takes more time to describe it. Basically, when you're rounding a number, the more round that it is, the less accurate it becomes. So 19 million, which is very round, is in fact not that accurate, but it's accurate enough and it's easy to say. Instead of saying 19,013,000, it takes a little bit more time, right? Whereas 19 million is just 19 million. So this is easier to say, yes. It's more round, yes, but it's less accurate. Let's say someone asked us to round this number to the tens of millions. I'm going to delete this. So tens of millions is right here. It's in front of the millions, right? So what would we do? We look to the number right next to the digit that we're rounding to. So in this case, the 9, which is one of these numbers. So what happens is that the 9 and everything around it, everything after it gets turned to 0. And because we're in this case, we add 1 to the digit that we're rounding to. So 1. So the 1 is going to become 2, and everything after it is going to become 0. So this becomes 20 million. Now, why do we do this? Why do we add 1? Why do we add this 1? Whereas in the other case, we just turn everything, the number and everything after it into 0. Well, basically, you need to think about it like this. Let's say I give you the number 38, right? And I ask you to round it to the tens, which is right here, right? What you're looking for is this number when you're rounding, right? So let's just turn this red. When you look to the digit that's right after it, so this 8, what you're basically looking for is this number closer to 30 or 40? Right? If this number here, if the ones is basically if the digit right after the one that we're rounding to is 0, 1, 2, 3, or 4, then it's closer to 30. So I'm just going to turn it to 0, right? But if it's 5, 6, 7, or 8, or 9, it's closer to 40. So I'm going to turn this to 0, but I'm also going to make this one more. So it's going to become 40, right? That's what I did here as well. When I ask you to round this number to the tens of millions, we look to the 9 to figure out, okay, is this whole number closer to 10 million or 20 million? And because this is a 9, then the number as a whole is closer to 20 million. Now, it is more accurate to say that this number is 19 million than it is to say that it's 20 million. But here we were asked to round to the tens of millions. So this can be done with decimal numbers as well. And it's especially useful with decimal numbers because in decimal numbers, for example, you might get a division where you might get a random division, right? Where you might get a result like 2 points and then just random numbers afterwards, right? Just nonsense, nonstop, right? And this just goes on forever. This is not an answer, right? You can't write this whole thing. And then you can't do calculations with this number either. This is true especially for pi, where you have, for example, 3.14 and then I don't remember the next digits, 15 something. But pi, its digits just go on into infinity. They never stop, right? But what we do when we write 3.14 is we round pi to the hundredths, right? We've rounded it to the hundredths. Why? Because the next digit, if I remember correctly, is also 1. So we say, okay, this number is very close to 3.14. Okay, so let's say that you're given a division, right? Let's say you're given the division 458 divided by 7. Now, if you do this division, what you're actually going to find is 65.42855714. That's all that I'm going to write, but it continues. And you'd have to write all of that. But let's say you are told in the exercise, do the following division and round your result to the tenths, right? What you do is you'd find this whole thing, and basically you could stop. You wouldn't have to do any of this, right? Once you found the tenths and the digit right after it, you're done. You don't need to do anything else, right? What you do is you'd look at the tenths, and then you'd look at the digit that's right after them, so the 2. Since the 2 is a small number, we are going to round down. That's what this first case is. It's rounding down, where we turn this number and everything after it into zeros, right? And we leave the digit that we were rounding to alone. We don't do anything to it. And because it's a decimal number, we can delete these zeros as well. They're not necessary. So my result comes 65.4, which is much more manageable and much easier to write, and so on and so forth, right? Let's say, however, that we are being asked to round our result to the hundredths. The hundredths are here. I would look to the digit on their right, so that would be the 8. Because 8 is a big number, right? We're going to be rounding up. That's what that is called. Just turning all of these into 0, but also adding 1 to the digit that we're rounding. So the 2 becomes 3. And again, because it's a decimal number and the zeros are past all the numbers in the decimal part, we can just delete them. This becomes 65.43, which is more accurate than what we wrote before, where we wrote 65.4, but it's also less round. Rounding, again, is basically a trade-off for accuracy. It makes the number easier to write and manage and calculate with, but it's less accurate, right? And the more you round, the less accurate it becomes. Again, this, where we just make everything 0 and do nothing else, it's called rounding down. And this is called rounding up. So that will be all for today. Tomorrow we'll solve some more examples together. Bye.